the early hours of the morning, a mission controller sits deep inside a command bunker, staring at a screen filled with glowing markers. 18 drones have just crossed into Russian territory, and from this point forward, every second matters. The distance ahead is enormous, hundreds of kilometers of defended airspace standing between the drones and their destination. Yet the formation continues forward without hesitation. Suddenly, 2 missiles launch from a Russian Tor-M2 air defense battery positioned far ahead of the formation. The interceptors streak through the sky at incredible speed, and within moments 2 drones disappear from the controller's display. The first losses arrive faster than expected, but surprisingly, the mood inside the bunker does not collapse. The planners had already anticipated casualties. Losing a few drones was never the concern. The real question was whether enough of them could survive to continue the mission. As the remaining aircraft push deeper into hostile territory, it becomes clear that this operation was never designed around perfection. It was designed around endurance. The drones continue their journey despite the losses, and the Russian defenders quickly discover a troubling reality. Every missile they launch costs significantly more than the drones they are trying to destroy. The economic equation is already becoming uncomfortable, and this is only the first defensive layer standing in the drone's path. Before we continue, if you're enjoying this breakdown of modern warfare and military strategy, consider supporting the channel by leaving a like and subscribing. It helps us continue bringing you detailed stories and analysis from conflicts around the world, and it ensures you never miss future updates. Now, let's see what happens next as the surviving drones head toward an even greater challenge. The first Russian defenders quickly realize they are facing an unusual problem. Although the drones are simple compared to advanced military aircraft, their low cost makes them difficult to counter efficiently. The surviving 16 drones continue flying deeper into Russia, forcing commanders to consider increasingly expensive responses. Reports move rapidly through the chain of command, eventually reaching a nearby airbase where one of Russia's most capable interceptors is ordered into action. Within minutes, a MiG-31 roars into the sky. Built to hunt bombers, cruise missiles, and high-speed threats, the aircraft represents the pinnacle of Russian interception capability. As the pilot accelerates toward the incoming drones, confidence remains high. On paper, this should be an easy engagement. The fighter's radar is powerful enough to detect targets at extraordinary distances, and its missiles were designed to destroy threats long before they reach their objective. Yet as the pilot closes in, he encounters a problem few expected. The drones are not behaving like traditional military targets. They are flying slowly, maintaining predictable routes, and presenting radar signatures that challenge the very systems designed to destroy them. What appears to be a straightforward interception suddenly becomes something far more complicated. As the MiG-31 approaches firing range, the pilot prepares for what should be a routine missile engagement. The fighter's radar locks onto the incoming targets, and an advanced R-77 missile is launched toward the lead drone. Everything appears normal during the first moments of flight. The missile races forward at tremendous speed, guided by sophisticated electronics designed to track enemy aircraft. Yet moments before impact, something unexpected happens. The missile effectively loses interest in its target. The drone's slow speed and tiny radar profile cause problems for the seeker system, which begins interpreting the drone as background clutter rather than a legitimate threat. The missile veers away and crashes harmlessly into the ground. The pilot attempts another shot from a different angle, hoping for a better result. The outcome is nearly identical. Once again, the missile fails to maintain a lock. The realization is stunning. A fighter designed to dominate the skies is struggling against aircraft that cost only a fraction of the weapons being used against them. The pilot quickly calculates the situation and understands the problem. Even if future missiles perform better, he does not have enough ammunition to engage every drone. After exhausting valuable weapons without success, he is forced to disengage. The drones continue forward untouched, leaving Russian commanders searching for another solution. Farther ahead, one of Russia's most formidable defensive systems begins tracking the approaching formation. An S-400 battery detects the drones from long range and carefully monitors their progress. Normally, the appearance of hostile aircraft would trigger an immediate response. The system was designed to destroy advanced fighters, cruise missiles, and even ballistic threats. Yet the battery commander hesitates. The drones are visible, but engaging them presents a difficult dilemma. Every interceptor carried by the S-400 represents a valuable resource, and each missile costs an extraordinary amount of money. More importantly, the commander cannot be certain what might follow behind the drones. If these aircraft are merely the first wave of a larger attack, wasting precious interceptors now could leave critical areas vulnerable later. The commander watches the targets move steadily across his display. Minutes pass. The drones remain within range, but no launch order comes. Eventually, the formation leaves the engagement zone entirely. What appears to be inaction is actually a strategic calculation driven by limited resources and competing priorities. For the drone operators monitoring the mission from afar, the decision feels like a major victory. Yet even as they celebrate, another obstacle is already waiting ahead, one that threatens to bring the entire operation to an abrupt end. Suddenly, the navigation systems inside the drones begin experiencing severe disruptions. Signals that had guided them for hundreds of kilometers become unreliable as Russia's electronic warfare network activates. Across a vast area, powerful jamming systems flood the airwaves with interference. The effect is immediate. Several drones begin drifting from their intended paths. Some struggle to maintain direction. Others start wandering away entirely. One crashes into a wooded area while another disappears after veering off course. For a moment, it appears that Russian electronic warfare may accomplish what missiles and fighters could not. Inside the control center, tension rises dramatically as operators watch valuable aircraft lose their bearings. Yet amid the confusion, something unusual stands out. Not every drone is affected. A select group continues flying with remarkable precision despite the intense jamming environment. While other aircraft stumble blindly through the interference, these drones remain locked onto their course. Their behavior suggests they are relying on something far more advanced than satellite navigation. The survival of the entire mission now depends on these few aircraft. If they can continue toward the target, the operation remains alive. If they fail, everything accomplished so far becomes meaningless. The answer lies in a technology specifically designed to overcome exactly this type of electronic attack. The reason some drones remain unaffected soon becomes clear. Unlike the others, these aircraft are not relying solely on GPS signals. Instead, they navigate using stored imagery and onboard visual recognition systems. Before launch, engineers loaded detailed maps of the entire route into the drone's memory. As the aircraft fly, cameras constantly compare the landscape below with reference images. Rivers, forests, roads, rail lines, and industrial facilities become navigation markers. Even when electronic warfare blocks satellite signals, the drones can still determine their position by recognizing the terrain beneath them. This approach transforms the mission. Russia's jamming network was designed to blind drones dependent on GPS, but these aircraft effectively navigate by reading the world around them. The technology allows them to continue advancing even while surrounded by some of the most sophisticated electronic warfare systems in existence. For the operators monitoring the mission, the relief is enormous. The surviving drones push onward, maintaining course despite everything thrown at them. Yet the most dangerous phase of the operation is still ahead. Closer to the target, a short-range air defense system waits with a fresh supply of missiles and far fewer concerns about conserving ammunition. As the formation approaches the final stages of its journey, a Pantsir air defense battery acquires the incoming drones. Unlike earlier defenders, this commander has both a clear target picture and weapons specifically adapted to counter drone attacks. Missiles launch in rapid succession, and this time the results are immediate. Several drones are destroyed as fragments scatter across the countryside. For the first time, the defenders begin reducing the formation at a meaningful rate. Yet something strange becomes apparent as the engagement continues. The majority of destroyed drones belong to the front of the formation. The commander follows standard doctrine, prioritizing the closest contacts and engaging them first. What he does not initially realize is that the drones leading the formation are largely expendable decoys. They exist primarily to absorb defensive fire and expose the locations of air defense systems. Behind them fly the aircraft carrying the mission's most important payloads. By the time the commander recognizes the difference, valuable seconds have already been lost. Missiles continue firing, but many of the drones that truly matter are now approaching the edge of the engagement envelope. The defenders score additional kills, but the outcome remains uncertain. The operation was designed around sacrifice, and those sacrifices are beginning to pay off. With only a handful of aircraft remaining, the mission enters its decisive phase. The surviving strike drones break formation and begin maneuvering toward individual objectives. Each aircraft carries detailed imagery of a specific target and now transitions from navigation mode to terminal attack mode. Cameras compare the structures below with stored reference data, ensuring the correct buildings are identified before impact. One drone heads toward a major reactor column. Another targets a compressor facility. Others focus on supporting infrastructure essential to industrial production. Every remaining aircraft has a precise role. Defenders continue attempting interceptions, but opportunities are rapidly disappearing. The drones are now too close to their objectives. Years of planning, technological development, and operational adaptation have brought them to this moment. The mission is no longer about surviving defenses. It is about delivering the final blow. As the aircraft descend toward their targets, the true purpose of the operation finally becomes visible. This was never simply an attack on buildings. It was an attack on production capacity, logistics, and the industrial foundation supporting military operations. The first impact triggers a chain of events far larger than the drone itself. Explosive charges rupture critical equipment operating under extreme pressure, releasing volatile materials that ignite almost instantly. A massive fireball erupts above the facility, sending thick smoke into the sky. Additional drones strike nearby infrastructure, damaging compressor systems, chemical processing equipment, and power distribution networks. The destruction spreads well beyond the immediate blast zones. Facilities designed to operate as interconnected systems suddenly lose key components required for production. Even structures that survive physically may remain unusable for extended periods due to damage elsewhere in the network. For the operators who launched the mission, the objective has been achieved. A relatively small number of low-cost drones have penetrated multiple defensive layers, overcome advanced electronic warfare, survived fighter interceptions, and reached strategically important targets hundreds of kilometers from the border. The attack demonstrates a growing reality of modern warfare. Expensive defenses can be challenged by inexpensive, adaptable systems operating in coordinated ways. As smoke rises from the damaged facilities, military planners on both sides are left studying the same question. If a mission like this can succeed today, what might the next generation of drone operations achieve tomorrow?